Welcome to Mathic, where we help people fear less, build confidence, solve problems. All by explaining fundamental principles of calculations, so you don't feel awkward or scared whenever you need to deal with any numbers or numerical task. Today, we are going to be a bit geeky. We will learn some cool tricks to multiply double-digit numbers, all in our head. Whether it's 95 times 94 or 37 times 92, I will show you how to do it quickly and easily in your head. We are going to explore some fascinating insights that will turn you into multiplication master. So let's get our brains in gear and start multiplying like never before. There are three methods that we will explore. First one, multiplication of numbers close to 100, multiplication of numbers close to 50, and multiplication of any double-digit numbers. These methods were first published in a book called Vedic Mathematics in 1965 in India. So let's start with multiplication of numbers close to 100. Let's say we want to multiply 95 times 94. Firstly, we will evaluate what is the difference between these numbers and number 100. So 95 less 100 is minus 5. 94 less 100 is minus 6. Secondly, we must realize that the solution we are after should be a 3 or 4-digit number, given we are multiplying double-digit numbers. Thirdly, we will write first two digits of the result, being 95 less 6 or 94 less 5. In both cases, the result is the same, number 89. Next, we will find last two digits of the result, being multiplication of numbers minus 5 and minus 6. So the result is 30. Once we write the numbers together, we have final result of 8930, which is 8930. Let's try once again multiplying numbers 88 and 92. 88 less 100 is minus 12. 92 less 100 is minus 8. 88 less 8 or 92 less 12 is 80. So first two digits of the result could be 80. Minus 8 times minus 12 is 96. So last two digits of the result is 96. So the final result is 8096, or in other words, 8096. Let's try one more example. Now this will be a little bit more complicated. Let's try to use the same method for multiplication of 87 and 92. 87 less 100 is minus 13. 92 less 100 is minus 8. 87 less 8 or 92 less 13 is 79. So we should have the first two digits of the result. But we don't. Why? Because minus 8 times minus 13 is 104, which is 3-digit number. If we put together 2-digit and 3-digit numbers, we would get a 5-digit result. But given we are multiplying two 2-digit numbers, result should be 4-digit number in this case. So now what? Well, we will move first digit of 104, in this case number 1, into the first two digits of the final result, which will be increased by 1. So the final result will be 79 plus 1, that is 80, and 4. So 8004. Let's try one more difficult example of multiplication of 85 times 90. 85 less 100 is minus 15. 90 less 100 is minus 10. 85 less 10 or 90 less 15 is 75. Minus 10 times minus 15 is 150. So the last two digits of the result should be 50. First two digits will be 75 plus 1, that is 76. So final result is 7650, or in other words, 7650. Obviously, this method has some limitations once we get further from number 100. But don't worry for now, we will explore multiplication of any double-digit numbers later in this video. Let's move to method number 2, which is multiplication of numbers close to 50. We are using base of 50, which is 100 divided by 2. I will explain later why this is important. So let's multiply 56 times 54. We will use a similar approach as in method number 1. 56 less 50 is 6. 54 less 50 is 4. Multiplying 6 times 4 we get to 24. We have the last two digits of the result. 56 plus 4 and 54 plus 6 is 60. Now, in order to get first two digits of the result, we need to divide 60 by 2, because our base 50 is 100 divided by 2. So final result is 3024, or in other words, 3024. Let's try to multiply 52 times 58. 52 less 50 is 2. 58 less 50 is 8. 2 times 8 is 16, so last two digits should be 16. 52 plus 8 and 58 plus 2 is 60, so if divided by 2, first two digits should be 30. Final result is thus 3016, in other words, 3016. Now, let's try a little bit more difficult example of multiplication of numbers 54 and 55. 54 less 50 is 4. 55 less 50 is 5. 4 times 5 is 20, so last two digits of the result should be 20. 54 plus 5 and 55 plus 4 is 59. Divided by 2, we get the result of 29.5. We have first two digits of 29, but 0.5 will be moved to the next two digits, so we will increase 2 by 5 to get 7. So the final result is thus 2970, or in other words, 2970. Let's try one more similar example, multiplying of 52 times 57. 52 less 50 is 2. 57 less 50 is 7. 2 times 7 is 14, so last two digits shall be 14 for time being. 52 plus 7 or 57 plus 2 is 59. 59 divided by 2 is 29.5. So we have first two digits of final result of 29 again, with 0.5 being moved next to the line. So last two digits would not be 14, but rather 64. The final result is thus 2964, or in other words, 2964. Next, let's try to multiply numbers that will be close to 50, but one will be larger than 50 and another one will be smaller than 50. For example, let's multiply 52 times 46. 52 less 50 is 2. 46 less 50 is minus 4. 2 times minus 4 is minus 8. 52 plus minus 4 is 48. 46 plus 2 is 48. 48 divided by 2 is 24. Now, as the last two digits of the result is minus 8, we shall subtract this 8 from 2400 to get the result. So final result is thus 2392, or in other words, 2392. Let's try multiplication of 57 and 47. 57 less 50 is 7. 47 less 50 is minus 3. 7 times minus 3 is minus 21. 57 plus minus 3 is 54. 47 plus 7 is 54. 54 divided by 2 is 27. 2700 plus minus 21 is 2679, our final result. Obviously, the further from number 50 we get, use of this multiplication method will be more difficult. With that, we get to multiplication method number 3, multiplication of any double-digit numbers. Here we will move step by step calculating result from back to the front. Let's imagine we are multiplying numbers with digits a and b times number with digits y and z. In step 1, we multiply the last two digits of our multipliers, that is b times z. In step 2, we multiply digits across and we will sum them together, that is a times z plus b times y. In step 3, we multiply first two digits of our multipliers, that is a times y. We will put these results together and somehow, quickly, we will get the final result. That was confusing, wasn't it? Well, let's explain this method at the example of multiplication of 37 times 92. In step 1, we will multiply last two digits of the numbers, that is 7 times 2. The result is 14. We can write last digit of the result, that is number 4, into our final result as a last digit. We keep in mind that first digit, that is number 1, has not been used yet. In step 2, we multiply digits in cross and we sum the results. In our case, we multiply 3 times 2 and 7 times 9. The results will be 6 plus 63. The sum is thus 69. We need to add number 1, the number that we kept in mind from step 1. Thus, our result is 70. We can write number 0 as the second last digit into our final result, while keeping number 7 in mind. Moving into step 3, we multiply first two digits of our multipliers. Multiplying 3 times 9, we get 27. We need to add number 7 that we kept from step 2 on top, so we get to the 34. We can write 34 as first two digits in our final result. So 37 times 92 equals 3404, or in other words, 3404. What about 73 times 84? Well, step 1, 3 times 4 equals 12. We write 2 as the last digit of our final result, keeping in mind number 1. Step 2, 7 times 4 plus 3 times 8. That is 28 plus 24 equals 52. We add 1 from step 1 and we get to 53. We write 3 as the second last digit of our final result and we keep in mind number 5. Step 3, we multiply 7 times 8 to get to 56. We add 5 on top from step 2 to get to 61. We can write 61 as the first two digits of the final result. So 73 times 84 equals 6132. Shall we try one more difficult example? 68 times 74. Step 1. 8 times 4 is 32. We write 2 as the last digit of our final result and we keep in mind 3. Step 2. 6 times 4 plus 8 times 7. That is 24 plus 56, which equals 80. We add 3 from step 1 on top to get to 83. We write 3 as the second last digit of the final result. We keep in mind 8. Step 3. 7 times 6 is 42. We add number 8 from step 2 on top to get to 50. So our final result is 5032, or in other words, 5032. So let's sum up what we have learned today. We have started with multiplication of numbers that are close to 100, using distance of multipliers to number 100 as levers for multiplication. Then we explain multiplication of numbers that are close to 50. We use distance of numbers to number 50 as levers for multiplication. Here we should not forget to divide interim result of the first two digits by 2, as 50 is 100 divided by 2. Lastly, we explain methodology how to multiply any double-digit numbers. Naturally, in order to remember these techniques and use them in calculation from top of your head, practice is the key. So please subscribe to our channel to get the latest training materials and information about our online courses. Thank you for watching and see you in our next video.